Alright, so starting out, factor by greatest common factor. If you notice our agenda still uses this word factor. We're really not doing anything too crazy new today. We're taking an expression and writing it as factors, meaning two smaller expressions in parentheses. So still just reviewing what we did last week, and your quiz on this is Thursday. Well, we've been working on it for a while. So.
Oh, we have, but I mean, like, right when we get back.
It's 4 days after you get back. Let me just double check that. Oh, it's actually Wednesday.
So
you make note, please Wednesday. Okay. So if you're not sure how to factor by greatest common factor, you should have just easily been able to look back in your bell work or look in your workbook in chapter 8 and see, oh, okay, I need to find something that all three terms can divide by. So who picked 4? What is it? 4 what? 4M?
Oh, yeah. Dude, I'm so tired. Now I get why I didn't go to sleep till 2 in the morning and then I woke up at 4. Why? Now it's 5:30 a.m. No, why'd you go to bed at 2? Because I couldn't fall asleep. I don't know what it is. I just couldn't fall asleep. I stayed up to 2.
Alright, so it looks like all three parts. A 4m to the third definitely has a 4 and an m. 20 divides by 4, and 100 divides by 4.
Correct. So the greatest common factor would be, according to my calculations,
4 and m. So, if I recall, this class kind of like the fraction method. You guys kind of like the fraction method, not the circling method. So, if I divide 4m from the first, the 4's cancel out, and I got 3m's. I'm taking 1 out, so I have m squared. 20 divided by 4 is 5. 2m's, I'm taking 1 out, so now I have m. Uh-huh. Yeah. Yeah. 100 divided by 4, 25. So this is the answer. You guys do know how to do that. Yeah, I know you can do it.
I got it before anybody else got it. Before I even had it in my mind.
Alright, number 2 doesn't have a greatest common factor. It says factor the trinomial. So that's when we kind of do our riddle. We need to find numbers that multiply to 17 and add to negative 18.
Oh,
yes.
17 and 1.
Yes, 17 is prime. So you got to think about that number in 1. So 1 times 17 and 1 plus 17 is 18. And since we need it to be negative, we'll change both their signs. Negative 1 times negative 17. So our answers, what letter are we using? X? X minus 1, X minus 17. Yep, spent quite a while on that. You guys are ready for a quiz with a little review? You remember that little riddle? Number 3, factor by grouping. So that means when we have 1, 2, 3, 4 terms, we'll just take it 2 at a time. And factor a greatest common factor out of each 2. Who's finished this problem? Thumbs up if you're
I have finished it in my imagination.
Alright, these both divide by 3. And they both have n squared. 6 divided by 3 is 2. 3n divided by 3n squared will leave you with 1. Anything over itself is 1. And these two both divide by 4. 2n plus 1. And we know it works because the parentheses match. 3n squared plus 4, parentheses 2n plus 1. That's everything. So, on Thursday, I did give you a short assignment. Not like a big spring break assignment, but just 8 problems factoring.
Anybody do it?
So, open your workbooks up to page 112.
Did anybody do it?
I forgot.
Hey, if Tyler forgot, I think everybody forgot. Hold on. So if nobody did it, we don't get a grade for it. Right?
Okay, if nobody did it, we don't get zeros for it.
Bro! What page is it?
Wait, then the zeros level up to 112. And everyone has the same grade.
Exactly.
So that lowers the class average.
Oh shit. We're supposed to do 1 through 8? Wait, we're ready to do 1 through 8? 1 through something. I don't know. I don't think it was that. It was like 3 problems. Oh, wait, who did it?
You were waiting.
22?
I don't remember, bro.
You did it. How many problems is it? That's 8 problems.
Yeah.
Yeah, I didn't even get to go. First zero of the quarter. Is this an 8 thing? It's fine. It's only like what? Mike killed my grade a little bit. It's not. You need like 3, 4 minutes. So I'm missing this one. Every single one. Doesn't it still give us a 0 if it's the first grade? But again, like everybody's in like no.
Guys, Tony did it.
What page is it?
What's the
Yo, I did. How is it? Miss. I didn't have it. I didn't have it.
No, it's 22.
Yeah.
No, that's 19.
Oh.
You didn't do half.
Can we do a redemption grade for this?
No, yes.
Bruh. This vlog is now on. I gotta be more I have to do all homework for every day before I do things.
I know you have a lot of love. What? What is that?
Oh, I got a new pen.
No, I just like your stuff. Alright guys, let's take some notes on one more thing. I'm not gonna break it. So we just did 3 types of factors and vectors. We did GCF, factor, trinomial, factor by grouping. Today,
Find each perfect square.
Point five.
Oh my god.
Well, no, one square is just one.
Exactly.
Okay, one square is one. Two square.
Dude, I swear, I'm gonna read everywhere. I'm gonna be a read kid. A read kid. What? Factor using square roots.
Okay, so not square.
So do we just do the same? But is this notes?
Alright, Paul. Yep, you can title your notes chapter 8-8. And today we're going to factor using square roots, which is the quickest and easiest type of factoring.
Let's go. Let's do it.
Yeah, factoring using square roots is the quickest and easiest.
Yeah, so that's also square root.
Yeah, you guys, this isn't like their topic. This is just like a warm up. You'll be successful square rooting if you remember the numbers that can square root. So 1 times 1 is 1. 2 times 2 is 4. I mean, really, you should just kind of know these by heart, right? So you're going to make a list now with kind of the goal of within the next few days of just kind of knowing these off the top of your head, pretty quickly. 3 times 3, 9, of course. You guys go. I know them. You guys make a list.
5 times 5 is 25. 6 times 6 is 12. 36. I kind of had a brain fart there.
7 times 7 is
7 times 7 is 29.
8 times 8 is 64.
8 times
9
8 is
times
64.
9 is 80.
9 times 9 is 81. 10 times 10 is 100. I just had a brain fart, okay?
I bet you did.
I only slept for an hour.
Just that one topic with me. I bet you be more responsible for sleeping time.
It's not even about that.
No, it's 100% sleep.
No, it's not.
You gotta prepare to go to
I have to
bed.
wake up at 4.
What time did you get in bed?
2.
Why are you getting bed at 2?
Because I was home late.
Cadence, tell me when that's missing. Okay. Gabriel, tell me when that's missing.
10 times 10 is 100.
100.
But 4 times 4 is 16.
There they are. Alright, so technically this section is called like factor special. It's called special numbers. So these numbers are pretty special because they can square root. Okay, so if you see these numbers in your problem, little like highlight has to go off in your head that these are special numbers and they can be square rooted. Well, 121 can. So this goes on forever. This is just the first 10 positive percent.
Want to hear that?
Yeah.
Okay.
I'm not right.
I was just making sure.
Yeah.
Tony.
What? I
Alright.
can't see that part.
So when you're factoring, we'll start here with this problem called the difference of two squares. It's kind of the theme of today's work.
Oh. Why you going around talking to me?
I'll do it.
Here's another heading if you want. And you can pick one example to copy from this slide.
One example. Alright. Wait. Let me see. Hold on.
So the first example just uses A and B. The second example is x squared minus 25. And the third example is 2 squared minus 64.
Which one do you think is the most convenient?
So basically, we're just taking.
Let's say you want me to pick. I'll pick number 2.
Okay, then we're doing it.
No, just one's fine. plus 0x minus 25, right? So it's a binomial because there's two terms. We know that's called a binomial. If it was a trinomial, it would just have had a 0 in the middle. Since there's a 0 in the middle, the problem doesn't show it, right? Like we don't just write zeros for no reason. So if there was a 0 in the middle, you would be doing the trinomial method. You would say what multiplies to negative 25 and adds to 0. Because there's a 0 in the middle. So what does multiply to negative 25 and add to 0?
25 and 0.
25 and 0. No. 25 plus 0 is 25. Aiden? Negative 5 times 5, when you add them together, makes 0. So this factors to x plus 5 times x minus 5. So instead of having to make the table, if you see that the number is special in the list we just made and that there isn't anything in the middle, you can just write to the square root. The square root of 25 is 5. And always use a plus and minus sign. Because those two opposite signs is what makes the middle 0. And this is just for a difference of two perfect squares. It's a pattern that you can memorize, and it's really quick. You really don't even have to use the table. You just think, oh, square root of 25 is 5. Okay? Let me give you another one to try right now. Something off the list. Let's try m squared minus 49. Factor that. Using the exact same method we just did. Two sets of parentheses. Put your m in. Do a plus 7 and do a minus 7. Really the quickest and easiest method of factoring. Though we can't tell you how to do that before we explain this one, so you understand that these two numbers do actually add to 0, which is missing in the middle.
Is somebody on? Or is anybody missing that's on the field?
It's not live.
I'm not excited to see.
Alright, I'll go ahead. Practice it.
I already got the
You guys, you want to remember this a long time. Okay, go ahead and write the problem and write the answer. You want to remember this until you're done school. This is on the SAT. This is on any college placement. In fact, after you get a 4-year bachelor's degree, when you go to get your master's degree, they make you take something called a GRE. It's like an SAT, but it's like a graduate SAT, and this will be on that test. This is like one of the most basic algebra problems that you'll see. You'll see it forever.
But in a more
You don't want to forget it.
But in a more advanced way, right?
Don't might be something exactly like this right on there.
Oh, but then like since you like answered like more complicated problems, maybe like the first one.
No, they'll put a basic question on there just like this. Very good.
That's a bad thing.
So write it down. Alright, so it's plus 8 minus 8, and the reason for that is oh yeah, the square root of 64 is 8 from the special list we made. Try this one.
What's this?
Is this what you meant by more complicated?
Yeah. Yeah.
It looks a little more complicated, but it's the same.
So
Same
that's
idea.
a test. I wouldn't know like what to do.
Well, it's your first time doing it, so this isn't a test. It's just an example. Okay, so same concept.
This is 16. 4. And then 81.
So I'm going to square root the left side and the right side. And I'm going to do 2 sets of parentheses. So the square root of 16 is 4, so I'm going to put a 4 both. And the 16 has a y with it, so it's 4y and 4y. The square root of 81 is 9. Has a z with it. And it's the same thing. Technically, there's a 0 in the middle, so we have opposite signs here for canceling out purposes. 4y plus 9z, 4y minus 9z. It's the square roots with a plus and a minus sign.
Human being. You don't even know. I'm the smartest person in this class.
Ready for another one?
Sure. Maybe.
Sure you are.
I just don't try.
You don't have to try, Tony.
Exactly.
Okay,
last quarter I got horrible grades because I didn't try. Then just bring down 3. Because 3 can go into 27.
Alright, these are not special, these are not special perfect squares. So, this is actually a two-part process. Okay, so we don't see anything that can square root, but actually what Tony said is absolutely right. We do see a greatest common factor.
Look at that. Look at that. I'm just too smart. Look at that.
You need to write this down. Always begin by taking a GCF when possible. Because some problems come disguised. It's a two-part problem. So here, yeah, I see that they both divide by 3. What else do they both have? B. So our greatest common factor will be 3 and B. And so left in parentheses, B squared minus 27 divided by 3. 9. Okay. So we took our GCF out. And now a perfect square is revealed.
We're not done with the problem.
So now we can keep going because 9 square roots to be 3, right? It's in the list. So this would be B plus 3, B minus 3, and I'm going to keep the GCF of 3B on the outside. So this problem had 2 steps, greatest common factor, and then factor by square rooting. Lots of factoring problems have multiple steps where first you take the GCF and then you use another method.
That's really
It's not weird to me because it's smart.
Yeah.
You guys want to foil it and check it?
No.
You guys trust it? You
Yeah,
trust
I
it?
trust it.
You trust that this is equal to that?
Yes.
No.
Tony always knows best. He does.
Alright, y'all go for it.
When it's either jump off a bridge or run across it.
Always jump off.
Always jump
Tony
off.
is the only one that's so odd. So motivated.
I haven't done it. Imagine my last year's pool fucking senior club. If you ever get the decision to jump off or run across the bridge, just jump off. The run or jump.
Tony, you went from a senior quote.
It might change. We got a lot of growing to do.
I don't know. This one could change.
Cross our fingers and ball.
Sorry about the answer. It's good. 5.
So 25 does square root. The square root of 25 is 5. 36 does as well. The square root of 36 is 6. So there's no greatest common factor here. I'm going to go right to parentheses. 5a and 5a go first. 6b and 6b go second. Use the plus and the minus. Well, that problem looks difficult because there's 2 letters, the numbers are kind of big, looks maybe more challenging than bell work. It's actually the quickest and easiest type of factoring. When you see those special numbers, you're happy. Oh, great, this is going to go quick. The problem with factoring is that there's we're not even telling you all the different methods this year. Like in Algebra 2, we tell you even more types of factoring. Just so many different ways to rewrite problems. So you just keep trying. All right, y'all. I think this is our last example.
X to the second power minus 5x.